Okay, so as we approach these sets of problems, what we need to keep in mind is that carbon makes 4 bonds, right? And hydrogen has 1 bond. What that translates to is that carbon can have a total of 8 electrons and hydrogen can have a total of 2 electrons, okay? So there's a general formula for what's known as saturated hydrocarbons. So you may have heard of an unsaturated or saturated fat. And what a saturated hydrocarbon is going to be, as a general formula, is CnH2n plus 2. What that means is, like in this first problem, we have carbon, there's 5 carbons, so that would be N equals 5. So C would be 5. That means that in order to have a saturated hydrocarbon, you would have 2N plus 2 hydrogen. So 2 times 5 plus 2 is 12. Now, you don't have to know that in order to figure out how this structure goes together, but I'm just showing you that that's a possibility, okay? Excuse me. So when we have C5H12, that would be a saturated hydrocarbon. What that means, the term saturated, it means that you've got the most hydrogens you can possibly have for a given area. So what that means is that if we're trying to look at C5H12, you're going to have the most hydrogens you can possibly have. So let's try by putting 5 carbons in a row. And there are different solutions to this. They don't have to be in a row. If it works so that you have the right number of carbon and hydrogen around, then it's probably fine. So I would put all my hydrogen out. Okay. And now we see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen. Now, when I say that you can have different arrangement of carbon, what I mean is, let me go over here and make this a larger space to work on, is that you could have also had something like carbon, 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 and you could have one of these carbons sticking off of there. That would absolutely work. You still have 5 carbons, and if you go through and put out all of the hydrogens, that would give each of the carbons 4 bonds. Then what we would have again here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if that means that if your formula works, that you've got a saturated hydrocarbon, as long as you have all single bonds and there's no rings, any type of arrangement there is fine. Okay. Now, what happens over here, though, when we go to C5H10, well, you removed 2 hydrogen from the saturated. It does not hit this formula. It is not the same as the formula of Cn, or Cn of times H2n plus 2. It's just CnH2n. So this plus 2 is gone now. What that translates to is something that we call 1 degree of unsaturation. Again, you don't need to know that in order to put together a formula or a structure, but sometimes it's a little bit easier to do that, okay? So I'm going to zoom in here just to give myself a little bit more space with the C5H10. Actually, no, I'm going to take this a different location so we could see it a little bit more clearly. C5H10. So what I have then is 1 degree of unsaturation. Sorry about that. What that translates to is I have either a double bond or we have a ring. So let me show you those two options. And this is one of the many options that will work. It's not the only option. So I'm going to start by putting 2 carbons with a double bond next to each other. 3, 4, 5. Now, I could have put that double bond anywhere in this line. I could have moved a carbon like we just did in the last one over so that it would be not in a line. That's fine. All of those will work if you play around with it. But now I need to put in 10 hydrogens, keeping in mind again, there are 4 bonds for every carbon. So since this carbon already has 2 bonds, then that means that it can only take 2 hydrogen. So that's 1, 2. And since the second carbon has 3 bonds, it can only take 1. Then we're going to put the rest of these hydrogen on. Oops. And you can look at that in comparison to what we originally had. So this is C5H10. Let me scroll over and remind you, this is C5H12. So on C5H12, we have a CH3 followed by a CH2. When we go to C5H10, we lose a hydrogen on both of these positions. So it's now CH2 followed by CH. Okay, so that will also work. If you have a double bond, you have to lose hydrogen next door to each other because otherwise you wouldn't have the appropriate amount of bonds for any given hydrogen, or sorry, for any given carbon. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 hydrogen there. Okay. Excuse me. To show you how this could work in a ring, if we take 5 carbons and place them in a ring, that would be 1, 2, 3, 4, 5. And so if we put those around to each other like this, each of those carbon have 2 bonds already. So they only need 2 more hydrogens. Excuse me. If you want to consider it, like the hydrogens that would be on the end kind of come up and then the carbons wrap back around to one another, if that makes any sense. If it doesn't, that's okay. Just keep in mind that we've got 5 carbons here, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 hydrogen. So from this point forward, every time that you have 1 more degree of unsaturation, what's going to happen is you're going to either add a double bond or take a double bond to a triple bond, or you're going to form a ring. And those are the 2 methods. Every time you take away 2 hydrogens, then we have to either consolidate, where we have a double bond between 2 atoms, or we have a ring. So the biggest thing that we got to keep in mind is that the hydrogens are something that I tend to put on last. But this might be something that you sort of find your own version of. So when it comes to C5H8, this is an example where we've lost a second set of hydrogen. So 2 more hydrogen have gone, which means that we have 2 degrees of unsaturation. What that means is that we can have some combination of double bonds, a triple bond, or rings that will allow us to only have 8 hydrogen. So what we could do is we could have a carbon with a triple bond to another carbon. We could have a carbon with a double bond, and then another double bond. Or we could even have, oh, sorry, you don't know how to do that yet. 5 carbons in a ring and a double bond. And that double bond could be anywhere. Any of those will work just fine. And there's a lot of other things that I'm not showing you that would work just fine as well. So I'm going to let you place the hydrogen in there to see if there are 8 as expected. Okay. I'm going to skip this next one because it's very much like the ring that we just did. And I'm going to go on to C6H6. Okay. So this tells you that it's a cyclic compound with alternating single and double bonds. Okay. We're going to put in C6. I'm going to put 6 carbons in a hexagon type of arrangement, just like that. And it tells you that they're alternating single and double bonds. Single, double, single, double. So each of these carbons has 3 bonds because it's connected to 1 double bond and 1 single bond. It only needs 1 hydrogen. And that is benzene. Benzene is a very important molecule that you have probably floating around you in many ways. Okay. Okay, so next it's asking us to consider C3H6. And there's 2 different molecular structures for these. Okay, well, let's think about this. We've got C3H6. Well, if it was 2N plus 2, that would give us H8, which means that we don't have 8. We have 2 less than that. We have 6. So that's 1 degree unsaturation. Remember, we said that we can fulfill that by either having a double bond, or if we have a double bond already, we can have a triple bond as the next thing, or we can have a ring. So those are our 2 options. We can have a double bond. Oops, sorry, don't know why that happened. Hydrogens would just need a few hydrogen here. There's your 6 hydrogen. Or we can put them in a ring. Now, you might have noticed these 2 things don't look alike. No, they don't. This is what you would call a structural isomer. Isomers are different arrangements of atoms in space, even though they may have the same formula. Okay, so let's look forward. So C4H8 has a lot of other options that you can do here. see if you can try some of those. It does have 1 degree of unsaturation. So keep in mind, you can move where that double bond is located. There's a lot of different structures that we can make as we get to bigger carbons. Note that C6H12 is not saturated. So we have 1 degree of unsaturation because C6, if it was 2N plus 2, that would be 2 times 6, which would be 12 plus 2 would be 14. So that's not going to work. And so there's lots of different options, though, that we have to put together 6 carbons and only have 12 hydrogens. We could have a ring of 6 carbons. We could have a ring of 4 carbons with 2 other ones sticking out. We could have a double bond in the C6H12 anywhere you want. You could do something really creative and have a double bond in the middle and really put them in different arrangements. But in all of those situations, what you should find is that carbon bonds 4 times and hydrogen will bond once. And so as long as you recognize that you need to have either a double bond somewhere or you need to have a ring, then you're good. And I hope that that makes sense. Okay, so as we drop down and have 2 fewer hydrogen, then that adds 1 more degree of unsaturation, which means that now we need to have another double bond or another ring, or we need to have, instead of 2 separate double bonds, we could have 1 triple bond. And so again, any of those will work just fine. So I hope that this demonstrates a little bit for you all about how to put these molecules together. So as you remove hydrogen, you do have to remove 2 of them at a time. So just one is a big no-no. And that way you can keep your carbon happy. Thank you very much.